These OLED displays make a great addition to any PIC project. In today's video I'll show how to connect them to a PIC and how to write the driver software. I'm using an OLED display here for this demo, but you can actually use the LCD version instead. It should work exactly the same. I just happen to like the look of the OLED displays. So today we'll look at how to wire this up to a PIC, the connections that you need to make, setting up the chip using the configurator, and we'll look also at the software you need to write to control this display. I'm using this Winstar display, but you can use any of the displays which use the Hitachi HD44780 display controller, and the way to recognize them is to look at the control signals. If the display has these enable, read write, register select and 8 data bits, then it's most likely a copy or a version of this HD780 chip, and it will work just fine with this software. Okay, let's get started. Now this is the connection diagram that I'm using here. First thing to note is that this circuit is going to be using 5 volts. I have an LED connected to pin 2 just for debugging purposes. These are the connections to the PIC kit, and the PIC kit is going to provide the 5 volt power. You can use a PIC kit 3 or PIC kit 4, either is fine. I'm using the interface to the display in 4-bit mode, so I have the lower 4 bits tied to ground and I'm using the upper 4 bits to transfer the data. I prefer 4-bit mode as it saves a few pins on the micro and the wiring up is a little bit easier. And the software will be easier if we keep the 4 data bits on the same port and in the same order as they're going to be used in. So I've used the bottom 4 bits on port C. You can read data back from the display, but I'm not going to do it this way. I'm only going to write data to the display. So I'm going to tie the read write pin low, which fixes the display into write mode only. It doesn't matter which pins you use for the other 2 control lines. In this case I've used RC4 and RC5. It's also worth adding that when you connect these wires up to connect your micro to the display, be very careful to connect everything up correctly, because a single wire in the wrong place or wires crossed over or anything like that and the display just won't work. You won't see anything on the display and it's quite difficult to figure out what's wrong. So I would just say be very careful, double check your connections, make sure everything's right before you go to the next stage. So first thing we have to do is start a new project, embedded standalone project. Next, and now we have to select our chip, which is going to be a 16F1613. Select it, can leave the tool for now, and we can go to next. We choose the latest compiler, 2.41, XC8 2.41. Next, and now we need to give it a name, so let's call it OLED demo. And that's created our project for us. Now the next, and it's created all these folders which will have files in them at some point in the future, but the next stage is to use the configurator, the MCC configurator, which will let us set up the chip very easily using the graphical interface. So we have to wait a few seconds for this to load and choose the option MCC Classic here, finish, and again we're waiting for the start screen to come up, and that's it. So now this is the configurator main interface. So we first look at the system module, and it's important that we choose the right clock for this project. So we're going to use the internal oscillator with the I/O function on the clock in pin, so we'll have that pin available to use. We choose from here internal oscillator, and we choose the clock frequency, which I'm going to use 4 megahertz, and that is essentially it for that. The other thing to select here is we deselect low voltage programming. That gives us another pin free to use, because the low voltage programming requires the master clear pin to be used as a master clear, and we don't need it to be used for that. So if you next go to the pin module to choose which pins we want to have inputs and outputs on here, and the master clear in fact here is pre-selected, but we can unselect the master clear now as we don't need that, and in fact we're going to select all our pins, available pins are going to be outputs, as we're only going to use outputs, and it's best to leave any unused pins as outputs. And the other thing you must remember to do is to deselect them as analog up here. For some reason it automatically sets that as an analog input, which we don't want. We want them to be all outputs as shown by those ticks there, and that's all we need to do for the setting up the chip. We're not going to use the interrupt module. System module is done. So once we've done that, we click on the generate button here, which is a little bit truncated, but the G button, generate, and that will generate our configuration files and save them for us, and we wait for it to say generation complete, and that is therefore done. So I can now click the MCC button again to close that configurator as we're finished with it. And if we now look inside our source files, we'll see it's generated a main file for us with just sort of the initialization which it's generated is called from that function, and the interrupts, if we wanted to use them we could uncomment this, but we don't need them in this project, and then our main while loop, which we'll put our code in there. All the MCC generated files are in here, but we don't really need to worry about them, and similarly there are header files in there, but we don't need to worry about those either. So that's our project ready to go, and we're ready to start writing code now. So the first thing that we want to do, which I always do on a new project, is to do a blinking LED. So I'm going to define the pin for the LED, which, if you recall from the schematic, is on port A5. So we define here our LED is going to be defined as lat A bits. Those are the output latches for the port bit 5. So once we've done that, we can now put a little bit of code in our main loop, which will say LED could be equal to, say that again, it's going to be exclusive OR and equal to 1. So what that means is it's going to exclusive OR whatever the value of that port pin is, it's going to exclusive OR it with 1, which means it inverts the value. Each time it passes around this loop, it will toggle the LED. So it's going to blink the LED, but it's going to be very fast. So we'll also put into here a little delay, milliseconds. 200 should be enough, and we'll program that and see what happens. Now if you didn't select the tool earlier, it will ask you at this stage what tool you want to use, and so I'm going to use, so whatever tools are connected, plugged into the USB will show up on this list, and I only have the one tool, so I'll choose that and say OK, and then it should carry on compiling that and downloading it. It's going to ask me to check that I've got the correct chip, and I'm going to say don't show me that again. OK. Yes, I forgot to do that. As I said earlier, I want to power this project from the PIC kit, so I have to go over to the project properties, select the PickKit 4, choose from this drop down here list, choose power options, and just click on power target circuit from PickKit 4. So make sure that's ticked, and we need to have 5 volts on here. So as long as we've got 5 volts, we're good. So I can now OK that and try that programming again, download and we'll make and program the main project. Programming complete and LED blinking, so that's all working fine. Okay, so the next thing we need to do is to start writing some code to control the display. So the very first thing is, let's put some definitions for the pins we're going to use. So let's copy those in, and there we have the two main control pins, the enable and the command or data select pin. The other thing we'll need is just a couple of definitions here, which we will need later. You'll see why we need those in a short while, but we're just going to make the two possible commands for the displayer to send data, as in text to be displayed, or command to do the settings on the display. So those are going to be used later for that. So now we put in our first function. We'll just clear that out of the way, don't really need it. I'm just going to copy it in and go through it slowly. So this is the first function that we're going to need is a function that's going to write a character to the display. So we're going to pass it character ch, and we're going to tell it the mode, and now the mode is this command or data. So what this is going to do is it's going to split the character into two nibbles and then output them one after the other to the display with some delays in here to make it work correctly. So this section here starting setting the control line LCD RS to the right value to whether it's going to be command or data. Then we copy the data to the output port, mask it, copy the 4 bits that make up the nibble. Then at this point the LCD E, this is our strobe. In effect, when we strobe that high and low again, it latches the data into the device, and then we repeat the whole thing again for the second nibble, and that process writes one character to the display. So the next function we're going to add into here is going to be initialize the display. So this is going to write a series of commands to the display, all of these commands in a particular order, and which will get the display up and running. Yeah, there are a number of different examples and recommendations on the internet that I've come across, that recommend some different values possibly to put in here, but these are the ones which work well for me, and I haven't had any trouble with them, so I am sticking with them. So with that, we have enough to actually try the display and see if it's going to work. So what we need to do in our main program is first call the initialize LCD init, or rather OLED init, and then we're going to write to it. Let's copy that. We're going to write a character to it, so we put a character in here, A. And we're going to tell it that is data rather than a command, and that should write to the display. Let's see what happens. That's great, so that works, so we can write to our display. Now we could just use this function here and just repeat it like this and write something, change the character and write a hello write a hello world type of a program, but it's a little bit tedious doing it that way, so let's make a function here that can write a string. So let's go back up a little bit outside our main function, and let's paste our function in and we'll go through it. Right, so this is our LCD, you call it I keep mixing LCD and OLED, but it's kind of the same really. So LCD write string, so all we do is we pass this a pointer. This star string is a pointer which is going to point to the start of the string, and you know, I'm sure as you know, a string is just an array of characters. So we pass the string to it by passing the start address, the pointer, to the start of the string. So then we just go through this in a loop, and we keep going through the loop until we find a null, which is a 0 in the string. So strings are always terminated with a null, so we're just going to loop through this until we find that null at the end. So each time we go around this loop, we write one character to the LCD display, and then we increment the index each time for the next character. So let's get rid of that we don't need that anymore, and let us put in that. So here we're going to use our function to write an entire string, and there's our string. So let us program that and see what happens. And there we have it. It works. So far so good. But let's say now we want to write another line, because we've got 2 lines on our display. So we want to really write to the second line to see how that is done. So if we copy that write string and let's change it to something different, so we'll just say just call it line 2. Now we want to write that to line 2, but how do we do that? Well, there is a command to do that, and that command is C0. So if we write that command as a C0 to the display, it'll tell it to go to the first character position on line 2, and then we'll write line 2. So after that, let's say we want to write something else to line 1. So let's copy that line again, and this time we'll say hello world line 1. We'll just add that on. So how do we now go back to line 1? Well, there is a command for that as well. You could in fact use this init again, but there is a command, so we might as well use it, and the command is O2. So we just write that command, and that will then let us go back to line 1 and write something. So let us also put a delay in here. Milliseconds. Let's say 2000, so that we have we can see there'll be otherwise it'll be too quick and we won't see this first part. So what we should see is it should write hello world, and then on line 2 it should write line 2, and then after a couple of seconds you go back to line 1 and write hello world line 1. So we should see those things happening. Okay, let's program that and see what it does. Here we go. Hopefully it'll compile again. Verified programs. Yep, that's worked. Fantastic. And even after a short delay, as expected, we see it writes back to line 1 again. So there we have all the functions necessary now to write to the display and use that in a project. So the last thing I want to look at, and I almost forgot about it, but it is a lot of fun to do with OLED displays or LCDs, is scrolling the text. So now there is a command for scrolling which shifts the display one character at a time to the left or right, and that command is this one, 18 hex we write to, and that will shift the position of the display one character to the left. So one character is not much use on its own, so what we really need to do is put a loop around this so that we can let it do a number of shifts at a steady pace. So first I'm going to need a character to count and then I'm going to need a for loops like this. And these lines inside the for loop. Let's adjust the spacing of that. Okay, so that is going to go around the loop. Every 200 milliseconds it's going to shift the display one position to the left. Okay, let's try that and see what happens. Let's go. There we go. That definitely scrolled, and what we can see there is it eventually wraps around in the memory and scrolls past again, even though we are just continuously shifting the display to the left. You can see the effect of having a fixed line length in the memory. It causes it to wrap around in that way. So as it turns out, in this device, in this chip, it has a line length of 64 characters. So let's see what happens if we put in a line which is 64 characters long, including a space on the end. And let's program that in and see what the effect of that is. Okay, let's program it. Okay, it's programmed. See what happens. So we can see the string scrolling all the way across all the characters that were hidden, and it wraps around kind of seamlessly because we're matching the number of characters in our string with the number of characters that it can display. So now it just keeps rolling around, looking quite nice. So I hope you found that useful, and let me have any comments underneath, questions, comments, and I'll do my best to answer them. And as always, please like and subscribe. Thanks for watching.